Hi guys, today we are looking at this 2021 paper, paper 1. This is the advanced subsidiary level paper. Okay, it's a 2-hour paper, and as always, whenever you're answering or taking this exam, make sure that you read all the instructions and follow them as they are stated there. Okay, so let's quickly get into it. Question 1 says find the first 3 terms in ascending powers of x in the expansion of 1 minus px to the power of 6. Now, the good thing about this advanced subsidiary is that they are formulas at the back. So in case you forget anything, you can always refer to these formulas. But I always say it's a good idea even before you go to the exam, you know some of these formulas and not just rely on the ones that are listed. Okay, so with the first one, we have to find the first 3 terms in ascending powers. So ascending, that just means the powers of x are going up. So you start from 0, 1, 2, 3, and so on. Now, in the formula sheet, you will take note that we are given the binomial expansion formula, which is a plus b to the power of n. This is given as a to the power of n plus n choose 1 multiplied by a to the power of n minus 1 times b to the power of 1. Then you keep going, keep adding until you get to b to the power of n. So this is the formula that is given, and you need to keep in mind that n choose r, this is equal to n factorial over r factorial multiplied by n minus r factorial. And remember that r factorial means r times r minus 1 times r minus 2 and so on. So for example, 5 factorial, this is 5 times 4 times 3 times 2 times 1 and so on. So 6 factorial. So 6 factorial will be 6 times 5 times 4 times 3 times 2 times 1 and so on. Okay, so when you're given a term like this, a binomial to expand, you can see that here in the middle we have a plus and over there we have a minus. So what you should first do is rewrite this subtraction with a plus in the middle. So I have 1 minus px to the power of 6. Rewriting it with a plus in the middle, I can rewrite this as 1 plus negative px to the power of 6. So this 1, this is going to be my a, and then minus px, that is going to be my b. And then I'm going to substitute them into that formula. So very important that whenever you have a minus, you should first separate them like that. Okay, now writing down the first 3 terms, the first 3 terms is just a to the power of n. So here our n is 6. So I have 1 to the power of 6. And then the second term, I have 6 choose 1 multiplied by my a, which is 1 to the power of 5. And then you multiply this by your b to the power of 1. And you should always notice that the powers of a and b, they always add up to n. So here I have a which has a power 6, b which has a power 0. 6 plus 0 is 6. Here there's power 5, there's power 1, they add up to 6. And the next one, I would have 6 choose 2 times 1 to the power of 4 times negative px to the power of 2. Again, you can see that this 4 and this 2 add up to 6. Okay. So this is as far as we'll go because we are only asked to work out the first three terms. So 1 to the power of 6 is 1, and then 6 choose 1. This you would type in on your calculator. On the calculator, it should look like the 6, the C, and then 1, which is 6 choose 1. So 6 choose 1 is 6 multiplied by 1, because 1 to the power of 5 is 1, and then negative px to the power of 1 is just negative px. Then 6 choose 2, this is 15. 1 to the power of 4 is 1. And then negative px squared. Whenever you square negative, the answer is positive. So this will be px, everything squared. So the negative is gone because whenever you square a negative, if I have negative 1 times negative 1, the answer is positive. So negative 1 squared is the same as positive 1 squared. So that's why the negative is not there. And simplifying this, this is 1 minus 6px. So this negative will come multiply, they become negative, and then we have 6px. And then this one is positive, so I have 15. This px squared is just p squared x squared, so this is 15 p squared x squared. So those are the first three terms in the expansion. All right, then it is given that the coefficient of x squared in the expansion of 1 minus x multiplied by 1 minus px to the power of 6 is 0. Find the non-zero value of p. Okay, so here what we don't want to do, because this question is only 3 marks, is we don't want to find the entire expansion of 1 minus px to the power of 6 and then multiply each of the terms by 1 minus x, and then from there work out what the coefficient of x squared is. That will take quite a lot of time, so we don't want to do that. So what I can do is this 1 minus x, I have 1 minus x multiplied by 1 minus px to the power of 6. I can rewrite this as 1 minus x, and then this one here, I am not sure, I don't know what, or I haven't worked out what the entire expansion is, but I know that the first three terms are 1 minus px plus 15 px squared, and then the next term, it'll be some number there, and then p to the power of 3, and then x to the power of 3, and then it'll continue like that. Okay, so we don't need to know what any of those terms are. Now, the reason why we don't need to know what any of those terms are is because we're looking for terms that have x to the power of 3. So what you do is you're going to multiply terms in the first bracket with terms in the second bracket, and then see which ones give you x to the power of 2. Now, the only way I can get x to the power of 2 is if I take this negative x, and I multiply it with this term here that has an x, because when the two x's multiply together, then I'll have x to the power of 2. The other way I could get that is if this one here multiplied with this term that has x squared. So this one must multiply with this term that has x squared. Now you can try any other combination. If I take this 1 and I multiply it with this term, I wouldn't get a term with x squared. I would have x to the power of 3, which is not what I'm looking for. I could take this x and multiply it with the 1. That would give me only x and not x squared. So that's not what I'm looking for. So the only way to get a term that has x squared is to take the 1 multiplied with a term with x squared, and then a term with x multiplied with a term with x. So when I write this out, I have 1 multiplied by 15 p squared x squared. That's the first term, and then you must combine it with this one here. We have minus x I'll put it in brackets. This is minus x multiplied by negative 6px. So this is the term with x squared. Okay, so this is how to get the term with x squared. You're grouping them. You look at terms in the first bracket and terms in the second bracket and say, how can I group them in order to come up with a term that has x squared? So if I multiply the one with 15p squared x squared, I will end up with an x squared, and then the minus x and the minus 6px, that will give me a term that has x squared. And then when I combine these two together, then I will be able to work out what the coefficient of the x squared term is. Okay, so simplify this, we get 15p squared x squared. And then here I have a negative and a negative. This will give me a positive. And then I have 6p x squared. All right, and then we can factor out the x squared. So this is, if I take the x squared out, you say 15p squared x squared divided by x squared, I'll be left with 15p squared. And then this one, 6p x squared, if I take out the x squared, I'm left with 6p. Okay, so this is the term with x squared, and then the coefficient is 15p squared plus 6p. Okay, now what else are we told? We're told that the coefficient is 0. So that means 15p squared plus 6p is equal to 0. So the coefficient, this is equal to 0. So we have 15p squared plus 6p. This is equal to 0. Then now we solve for p. So we can see here that 3 is a common factor and p is a common factor. So we take 3p out. So 15p squared divided by 3p, this is 5p. And then 6p divided by 3p, this is 2. Okay, so we have two terms multiplying and the answer is 0. It means that 3p is equal to 0, or it means that 5p plus 2 is equal to 0. With the first one, if 3p is equal to 0, we can divide by 3 on both sides. This means that p is equal to 0. But remember that we're looking for the non-zero value of p. So p is equal to 0 is not actually the solution that we're looking for. So here we have 5p is equal to negative 2. So this positive 2 goes to the other side, and then we get a negative 2. And then dividing by 5 on both sides, so divide by 5, we get p is equal to 5. So this is the non-negative value that we're looking for. Sorry, not non-negative, non-zero. Non-zero value. Okay, right. So quite an interesting question. Make sure that you read it and then understand what exactly you are being asked to do in the question. Okay, number 2, we are told that the diagram shows a parabola. It has a minimum of 1 and negative 3, so this is the minimum. And we have the x-intercepts, which are negative 2 and 4. Now we have to find the equation of the parabola. Now, one thing we should take note of is that the x-intercepts, these are what is also sometimes referred to as the roots of the equation. Okay, now when you're given the roots or the x-intercepts of a parabola, what you can do is you can call the first one alpha. So you can say alpha is equal to negative 2. So I'm just reading from the diagram. And then the second one, beta, is equal to 4. Okay, so what I have is I have the roots and I have a point that lies on the parabola. So here, take note that I have the roots plus 1 point on the parabola. Now, it's important to take note of this because that helps us in determining how to solve or come up with the equation of this parabola. Now, in the situation where you're given the roots and a point, it doesn't matter that the point is the minimum. It can be any other point as long as you have the roots of the parabola, as well as 1 point that is on the parabola. What you do is you will use this formula. So the equation of the parabola, you'll write it in this form, that y is equal to a, and then you say x minus alpha times x minus beta. So this a is what you need to figure out. You'll figure out what that is by substituting these points here. So the minimum will have x and y. This is my alpha, and then this is my beta. So I'll substitute all those points in here, and then I will solve for a. So now we go ahead and substitute. So we said our y is -3. So I have -3. This is equal to a. Remember, a is what we need to solve. And then x is 1. And then my alpha is 2. So 1 minus -2. And then x, this is 1. And then beta is 4. So this is all what I have. Now I go ahead and solve. So I can simplify this a little bit. This is -3a. Then here I have 1 minus -2. That is 3. And then 1 minus 4, that is -3. So this gives me -3 is equal to -9a. And then to solve for a, we divide both sides by -9. And then we have a is equal to +1/3. Or from here, let's say that I have 1/3 is equal to a, which means that a is equal to 1/3. All right, so now that I've figured out what a is, I now need to write down the equation of the parabola. So I'm just going to replace a, alpha, and beta in this equation. X and y, I'll leave them as x and y, because our equation of a parabola must have an x and a y. So we have y is equal to my a, which is 1/3, and then x, my alpha is -2, so I have x minus -2, and then x minus beta, my beta is 4. So this is 1/3 x plus 2, and then x minus 4. Now, usually we want to write this out in standard form. So in standard form, just take note that standard form, we have y is equal to ax squared plus bx plus c. So we'd have to multiply out our brackets. So we'll say this 1/3, I'll leave it out for a bit, and then say x times x, x times -4, 2 times x, 2 times that, and then at the end multiply everything. So this is 1/3. X times x is x squared. X times -4, this is -4x. Then 2 times x is 2x. and then 2 times minus 4, this is minus 8. Okay, then simplify first. This is x squared minus 4x plus 2x. This is minus 2x minus 8, and then this 1 over 3, multiply everything inside. So you'll have your standard form equation as 1 over 3 times x squared, 1 over 3 times negative 2x. This is negative 2 over 3x. And then 1 over 3 times negative 8. This is minus 8 over 3. Question 3. Solve the equation x to the power of 4 minus 81 is equal to 0. So this one, pretty simple to solve. We have x to the power of 4 minus 81 is equal to 0. We can have x to the power of 4 is equal to positive 81. So this negative 81 goes to the other side and it becomes positive. And then you take plus or minus the 4th root on both sides. So we have x is equal to plus or minus the 4th root of 81. And you get x is equal to plus or minus 3. So you're looking for a number that when you multiply it by itself 4 times, the answer is 81. So x is equal to 3. If you multiply 3 times 3 times 3 times 3, you get 81. You say negative 3 times negative 3 times negative 3 times negative 3, you still get 81. So those are the two solutions. So x is equal to 3, or x is equal to negative 3. You can also use difference of squares here. That is also perfectly fine. So factorizing, you can write this as x squared squared minus 9 squared. Okay, and then using the difference of squares, you'd write this as x squared minus 9 multiplied by x squared plus 9. This is 0. Then you would say the first bracket is 0, x squared minus 9 is 0, or the second bracket, x squared plus 9 is 0. This means that x squared is equal to 9. This means x is equal to plus or minus 3. You can see our answers are the same. And then with this one here, x squared plus 9 is 0. If you were to continue, you'd have x squared is equal to negative 9. And this one here has no real solution. Okay, so you cannot find a real number that satisfies this. So the only solutions you would get are plus and minus 3, like I did going in this direction. Okay, so hence solve the equation that the square root of a minus 4 to the power of 4 minus 81 is equal to 0. So here you can see that there is a similarity between 3a and 3b. Here with 3a we had x, and then here instead of x we have this bracket, and we know that here our x is always equal to positive 3 or negative 3. So when we have a question here that says hence, it means use what you got in the previous question to work out this next one. So from here we would then say that this is equal to 3 or negative 3, because when we had an x to the power of 4 here, we solved for x, we got x is 3 or minus 3, and now here the bracket has replaced the x, but they're still exactly the same. So from our answer in A, we know that the square root of A minus 4 is equal to 3, or the square root of a minus 4 is equal to negative 3. So we'll solve these two like this. So the first one, this negative 4 will go to the other side. Add 4 on both sides. You have the square root of a. This is equal to 3 plus 4. The square root of a is equal to 7. Then to get rid of the square root, I'll square both sides. the square root and the square will cancel. I get a is equal to 49. Then on the other side, this 4 also goes to the other side. So I have the square root of a. This is -3 plus 4. The square root of a. This is equal to +1. And then you square both sides. The square and the square root cancel. I get a is equal to 1. Okay. Now, number 4, an object is moving in a straight line. Its acceleration is in meters per second squared is given by a is equal to 60 plus 1, where t is time in seconds after passing through the initial velocity of the object is 2 meters per second. Okay, now with these questions here, you need to take note of a few things. There are some keywords that you need to remember, like here when it says initial velocity. What does it mean when we talk about initial velocity? So when we talk about initial velocity, this is telling us that when time is 0, so when t is 0, then our velocity is equal to 2 meters per second. Okay, so now let's get to what we're asked to find. Find an expression for the velocity of the object at time t. So we're given the acceleration. This is 6t plus 1. Now we want to find the velocity. So again, from the list of formulas, we know that the velocity is equal to the integral of the acceleration with respect to time. So we just go ahead and integrate 6t plus 1 dt. Okay, so integrating 6t dt, this you can say this is the integral of 6t dt. So you're integrating each of them individually, and then the integral of 1 dt. So, and whenever you're integrating a term that is being multiplied by a constant, the constant can always go out. So this is 6, the integral of t dt, then the integral of 1 dt. Okay, so integrating, the 6 will remain out. Now this t, this is t to the power of 1. So the integration is the reversal of differentiation. So there's a 1 here at the top. So when you integrate, you add a 1. So you'll have t to the power of 1 plus 1, which is 2. And then you take this 2 and you divide by it. So here, this 1, this is the same as 1 multiplied by t to the power of 0. So 1, so take note that 1 is equal to 1 multiplied by t to the power of 0. And if we integrate it the same way we did over here, where at the top you add 1, and then you take your number and divide by it, you would say this is 1. So the integral 1 dt, this is 1, this 1 here, and then you say t, 0 plus 1 is 1, and then this 1 you divide by it, and then you would just get t. So t times 1, which is just t. And then, of course, we always have a constant of integration, c. So simplifying this, we have 3t squared plus t plus c. That is our formula for the velocity. Now, this is when the initial velocity comes into play. So we are told that the initial velocity is equal to 2 meters per second. So that means that when t is equal to 0, then v is equal to 2. So I have my formula here for v, and it includes t, so I'm going to try and solve for c. So I'm going to substitute t is equal to 0 here, and v is equal to 2, and then use that to solve for c. So v is equal to 2, so I have 2. This is 3 times 0 squared plus 0 plus c. So this is 2, 0 plus 0 plus c. This means that c is equal to 2. So then the formula for the velocity, we have v is equal to 3t squared plus t, and then instead of writing c, you write 2. E, how far is the object O after 3 seconds? So how far, that means we're talking about the displacement. And again, from the formula sheet, we know that the displacement S, this is the integral of the velocity with respect to time. So I take my formula for the velocity and then I'm going to integrate it. So this is the integral. My formula for velocity is over here. This is 3t squared plus t plus 2 et. Okay, so integrating this, we have the 3, then again, powers of t at the top there, you add 1. So I have t to the power of 2 plus 1, which is 3. And I take this 3 and divide by 3. Then remember that this is t to the power of 1. So at the top, I'm going to add 1. So I have 1 plus 1, which is 2. And then I say 2 divided by 2. Sorry, not 2 divided by 2. Then I divide by 2. And then here, keep in mind that this is t to the power of 0 because t to the power of 0 is equal to 1. So I have 2 times 1. So at the top, you add a 1. So I will have my 2 there. It's not going anywhere. And I have t to the power of 0 plus 1, which is 1. And then I take this 1 and I divide by it. Then you always add a constant of integration. So my formula for the displacement, 3 divided by 3, this is t cubed. And then I have t squared over 2. And this is 2t plus c. Okay, now when we read the question, it moves in a straight line. We're not given anything to indicate that the initial displacement is not 0. So here we can take the initial displacement to be equal to 0. So initial displacement is 0. So that means when t is 0, then S is also equal to 0. And then we have to figure out what C is equal to. So we substitute, we have 0, S is 0, this is equal to 0 cubed, plus 0 squared over 2, plus 2 times 0, plus C. And here we can see that C, this means that C is equal to 0. So the formula for displacement, this is just S is equal to t cubed plus t squared over 2 plus 2t, and then our c is 0, so we don't need to write it. Okay, so the question said find the displacement or find how far the object is after 3 seconds. So what we want to do is we are going to substitute 3 in place of t. So after 3 seconds, we have S of 3. This is 3 cubed plus 3 squared over 2 plus 2 times 3. So this you can type it in exactly the way it is on the calculator. 3 squared, this is 27. And then here I have 9 over 2. Then this is 6. So I have 3 cubed plus 3 squared over 2. And this gives me 75 over 2 on the calculator. This is 75 2, and this is equal to 37.5, and this is in meters, and this is to 3 significant figures as required. Question 5, solve the equation 2 over cos theta is equal to 7 minus 3 cos theta, and we want an angle theta between 0 and 360. Okay, so we have 2 over cos theta is equal to 7 minus 3 cos theta. So as usual, when we have fractions, we always try and multiply the denominators out so we don't have any fractions, and then what we end up with is something that is easier to work with. So to get rid of this cos theta in the denominator, I'm going to multiply everything by cos theta. So this one times cos theta, and then this one times cos theta. So this 2 will cancel. So I have 2, and then 7 times cos theta, this is 7 cos theta, and then 3, and then cos theta times cos theta, this is of course cos theta squared. And then you need to take note that in short, we don't write it like this, cos of theta with bracket squared. We have cos theta squared, we write it as cos squared theta. So when you see this, you should know that it means cos theta multiplied by cos theta. And here, very important, the brackets do make a difference. So also take note that this is not the same as this. These two are not the same thing, okay? So here, what is being squared is the theta, the angle itself. Okay, and here what is being squared is cos of theta. So for example, here I would have something like cos of 9. This is equal to cos of 3 squared. That's what this means. I have cos of 3 squared, that means cos of 9. But if I have cos squared of 3, this is cos of 3 times cos of 3, which when you type it in on the calculator, you will see that you get 2 completely different things. So these are some of the mistakes that I see quite often. So take note of those so you don't make such mistakes. Okay, now what we have over here is 2 is equal to 7 cos theta minus 3 cos squared theta. So what we have here is actually, in fact, a quadratic equation. So to see that it is, if you cannot already, what you can do is make a substitution. You can say something like let cos of theta equal to m. So that means wherever you have cos of theta, instead of writing cos of theta, you're going to put m, or maybe let me make it x because we're so used to x. So let it be equal to x. So wherever I have cos theta, I'm going to put x. So I will have 2 is equal to 7. And then instead of cos theta, I put x. And then minus 3. This is cos theta squared. So here I will have x squared. All right. So solving a quadratic equation, you always want all the terms on the left and then 0 on the right. So this negative 3x squared will go that side, we'll get positive 3x squared. This 7x will go that side, you get negative 7x. And this 2 is already there positive, so it will remain like that. So now we have a quadratic equation. We want to solve it. You can either factorize, complete the square, or use the quadratic formula. So here I'm going to factorize. I look for 2 numbers. When I multiply them, the answer is 6, because 3 times 2. And when I add them, the answer is negative 7. So that's negative 6 and negative 1. So then I break up this negative 7 as negative 6 and negative 1. So I have 3x squared minus 6x minus 1x, which is just x plus 2. This is 0. Then I look at the first 2 terms. What do they have in common? They have 3x in common. So you take the 3x out. 3x squared divided by 3x is x. Negative 3x divided by 3x, this is negative 2. And then I look at the last two terms, I'm going to take out -1. The reason why I take out -1 is because I want the bracket that I end up with here to be exactly the same as that one. So I take out -1. So I say negative x divided by -1 is positive x. And then 2 divided by -1 is -2. Okay, and then we factorize again. So you may not from class have done it that way where you say you're factorizing again, but that is in fact what you are doing. You're looking at these two terms, these two, and saying, what do they have in common? They have the bracket in common. So you can take x minus 2 out, and then you say x minus 2 divided by this first term, you get 3x, and then negative 1 x minus 2 divided by x minus 2, you get -1. This is 0. And of course, the order that you write this brackets in does not matter. This is exactly the same as 3x minus 1 multiplied by x minus 2. They are exactly the same. Just like when I have 2 times 3 is the same as 3 times 2. There's no difference. Okay, so now that I have this, I need to solve for x. So I will have x minus 2 is equal to 0, or 3x minus 1 is 0. This means x is equal to 2, or 3x minus 3x is equal to 1, sorry. Is equal to 1, which means x is equal to 1/3. So I'm not done because I still need to figure out what theta is. So I have no space here. Let me see space at the back so I can continue. Okay, so right, I'll try and squeeze it over here. Obviously, when you're working it out in the exam, you will use all the space and you won't need to write any of these explanations, so you'll have plenty of space. Okay, so here we have cos theta. So remember that x is actually equal to cos theta. So just separate them so don't get confused. So we have cos theta is equal to 2, or cos theta is equal to 1/3. Okay, now this one over here, this is invalid because it is not possible to find a real number theta where cos of that angle is equal to 2, because cos of theta is always between -1 and +1. So it has a minimum of -1 and a maximum of +1. So it is not possible to solve this and get a real number. So the only one we are considering is this one, that cos theta is equal to 1/3. Now, the way that we solve this is we find what is called a reference angle. So we get our reference angle. Now, with this reference angles is that what we need to know is that every angle has a reference angle. If an angle is in the first quadrant, it is its own reference angle. So if you remember your cast diagram, so here, so you have an angle here, I'll call this angle alpha. Then an angle in the second quadrant, you would write it as 180 minus alpha, so this is alpha. Then in the third quadrant, you'd write it as 180 plus alpha. Then in the fourth quadrant, you'd write it as 360 minus alpha. So every single angle has a reference angle. So for example, 150 is in the second quadrant. So that means I must rewrite it as 180 minus something. So 150, this is 180 minus 30. So 30 is the reference angle of 150. Okay, and why are we talking about this reference angles? What is the significance? The significance, or why we talk about them, is that the sine, cos, and tan of an angle and its reference angle are equal. The only thing that may be different is the sign. So for example, if I work out sine of 150, you would see that sine of 150, this is equal to a half. And sine of 30 is also equal to a half. So if I know what sine of 30 is, I don't need to type in sine of 150 on my calculator, because I know that sine of 150 is equal to sine of 30. Now here, I know that cos of 30, this is equal to the square root of 3 over 2. Then from here, cos of 150, this will be square root of 3 over 2, except this will be negative. Why is it negative? Our cast diagram, because 150 is in the second quadrant, only sine is positive. So I take the value, the square root of 3 over 2, but because this is cos and it is in the second quadrant, I make this negative. Okay, so that's why we talk about reference angles in short. So when you're solving an equation like this, cos of theta is equal to 1 over 3, the first thing is to work out the reference angle. So you'll get alpha, that's the reference angle. This is cos inverse of 1 over 3. This you type in on your calculator. Because we're working in degrees, make sure your calculator is in degree mode. So cos inverse of 1 over 3 this is 70.5 degrees. So I'm writing it to 1 decimal place as required in the instructions. All right. Then that's the first thing, you find a reference angle. The second thing is to figure out in which quadrants is your solution coming from. So what you look at is this number over here, 1 over 3. 1 over 3 is positive. So this 1 over 3 here, it's a positive number. Then you ask yourself a question, in which quadrants is cos, because here my equation is in terms of cos, is cos of theta positive. Now why positive? Because this number here, I'm having cos of theta is equal to positive 1 over 3. So I'm looking at cos and the number on the right hand side is positive. So I say in which quadrants is cos of theta positive, and that's where I use my cast diagram. So it's positive in the first quadrant. So my answer is in the first quadrant and in the fourth quadrant from our cast diagram. So now if an angle is in the first quadrant, then we say that theta is equal to the reference angle. So theta is equal to my reference angle, which is 70.5 degrees. If it is in the fourth quadrant, angles in the fourth quadrant, we write them as 360 minus the reference angle. So we say theta is equal to 360 minus alpha. So this is 360 minus 70.5. This you just type in on your calculator. This is 289.5 degrees. So again, I've done a lot of writing here because I'm trying to explain my working, but when you are doing it in the exam, you just need to actually do the working. You're not necessarily going to have to explain anything, just do the working here. Okay, B, prove the identity that tan squared x minus sine squared x is equivalent to tan squared x times sine squared x. Now with proving identities, very important, you should always work on one side and one side only. Now the side you pick is completely up to you. Pick the side that looks more complicated, because then you would simplify it. So here, or at the side that you have some idea what you can do. Okay, so here I'm going to pick the left hand side. So I'm clearly letting you know that I've picked the left-hand side, and then I write down the left-hand side as it is. So this is tan squared x minus sine squared x. Now, as a general rule, if you don't know what to do, like you cannot think of, oh, what can I do here? And you have trigonometric functions like tan, cosec, and so on, rewrite them in terms of sine and cos. That is always a go-to rule that I've found almost all the time works. And then from there, you'll be able to figure out what to do next. So here I have tan squared x. I can rewrite that as sine squared x over cos squared x. And this is minus sine squared x over 1. Okay, so here I now have two fractions, and in order for me to add the two fractions, the denominators must be the same. Here, the denominator is cos squared, there the denominator is 1, so I can multiply this one by cos squared x over cos squared x. So then I would have sine squared x over cos squared x minus sine squared x times cos squared x over cos squared x. And now that the denominators are the same, you can add the numerators. So combining them to a single fraction, you have sine squared x minus sine squared x cos squared x over cos squared x. All right, then in the numerator, you can factor out cos squared, not cos squared, sine squared x. So you take out sine squared x, and then sine squared x divided by sine squared x is 1. And then sine squared x cos squared x, you have minus cos squared x. And then in the denominator, you just have cos squared x. All right. Then 1 minus cos squared x, this is an identity. So here you need to take note that 1 minus cos squared x, this is equal to sine squared x. And this comes from our most basic identity, which is that sine squared x plus cos squared x is equal to 1. Then you take the cos squared x to the other side, you end up with this one. So 1 minus cos squared x, I'm going to replace it with sine squared x. So I have sine squared x multiplied by sine squared x, and then this is divided by cos squared x. Then you can, of course, rewrite this fraction as sine squared x divided by cos squared x multiplied by sine squared x over 1. Now sine squared x over cos squared x, this is equal to tan squared x. And then sine squared x over 1, this is just sine squared x. And would you look at that? That is exactly what we have on the right-hand side. So this is the right-hand side. So I have shown that the left-hand side is in fact equivalent to the right-hand side. So key things here, very important. You must always pick one side only. You work on that side and that side only until what you have is exactly what is given on the other side. Right, number 6. Relative to the origin, the position vectors points A and B are given as follows. Then we are told that the point P lies on AB such that AP is 3/2 multiplied by AB. Find the coordinates of P. Okay, so we are given these position vectors. Now, we know that AP is 3/2 times AB. So if you can maybe have a sketch, this is not accurate because what we're given here is in 3 dimensions, but here I have only 2. So this is just a rough sketch for my own understanding. So I have 2 points here, A, B. I'm given their position vectors. So we have the position vectors. Okay. Okay. It's proving difficult to draw. Okay, so there we go. Those are our position vectors. So we are told that P lies somewhere on AB, so we'd have to have a line from A to B. Okay. Somewhere there, P will be maybe somewhere there. Okay, it's not to scale, obviously, it's just to illustrate. Okay, so we want to find the coordinates of P here. Now, one thing we should take note of is if we can work out the position vector of P, as in if we can find OP, then even if we have it in this form with X, Y, and Z, then these X, Y, and Z, those are going to be the coordinates of P. Okay, so we just need to find the position vector OP. All right, so we look at what it is that we are given, and we are given that AP, this is equal to 3/2 AB. Now, the way to think about these vectors is you are trying to get from one point to the other. I'm at A and I want to get to B. So if I'm at A and I want to get to B, I don't know what this vector is. So I do know this vector OA. So I can say I go from A to O, and then from O to B, that's the same as me going from A to O. So sorry, from A to B. So this is 3/2, and then I go from A to O, and then from O to B. Now from A to O, that's just the opposite as O to A, so I can say negative OA. So this is 3/2 negative OA plus OB. Okay, so this is what AP will be equal to. Now remember what it is we are looking for. We are not looking for AP. We know that if we can find OP, then we will be able to figure out what the coordinates of P are. Okay, so another thing we should take note of that we will make use of is that AP, this is equal to, so to go from A to P, I can go from A to O or negative OA, and then from O to P. So this is OP. And then if we change the subject of the formula, we can see that OP, which will help us to find the coordinates of P, this is equal to, this negative goes to the other side. We have AP plus OA. Okay, so now we have everything that we need, and then we can find out what OP is. So here I'm actually just working out OP. So OP, we said, is AP plus OA. What is AP? AP is this one here. So this is 3/2 multiplied by negative OA plus OB. And then we add OA. OA is just OA. right? Then I need to multiply out the brackets. This is negative 3 over 2 times OA plus this 3 over 2 with the OB plus 3 over 2 times OB, and then we add 8. Okay, and then we can see here I have negative 3 over 2 OA and positive OA. You add those two together, we get negative a half OA plus 3 over 2 OB. Okay, and now we're ready to substitute the X, Y, and Z vectors. So this is negative a half. What is my OA? It's 3, 3, and 6. Then I have 3 over 2. What is my OB? It is 1, 5, 2. And the way this works is that this negative a half just multiplies everything inside our brackets, and then we will add the corresponding terms of the vectors. So this is equal to negative 3 over 2. So this negative a half times 3. Then again, negative 3 over 2. That's negative a half times 3. And then I have negative 3. That's my first vector. So I've made it a little bit bigger so it's clear. And then the next one, I have 3 over 2 times 1, which is just 3 over 2. 3 over 2 times 5. That's 15 over 2. And then 3 over 2 times 2, this is 3. And now we just add the corresponding elements. So negative 3 over 2 plus 3 over 2, that is 0. Negative 3 over 2 plus 15 over 2, that you can do on your calculator. That's 12 over 2, which is equal to 6. And then negative 3 plus 3, this is 0. So we have our position vector of OP. This is 0, 6, 0. And therefore, the coordinates of P are 0, 6, and 0. That's it. B, show that AP is perpendicular to OB. Okay, now to show that two vectors are perpendicular, all you need to do is show that their dot product is 0. So to show that vectors are perpendicular, all you need to show is that the dot product is equal to 0. So you don't need to work out the angle between the two vectors using that long formula. You can simply just show that the dot product is equal to 0. That is sufficient. So AP, I worked out AP. Did we work out what AP actually was? No, we didn't. So we can still work out what AP is. So AP AP is a 3 over 2 of AB. So we want to find the actual value of AP. So AP, this is 3 over 2 of AB. So So this is 3/2. And we know that AB, this is negative OA plus OB. So I'm going through it a little bit fast because this is something that we have done already. This is 3/2. And then inside our brackets here, we have negative 336 plus 152. So this is 3/2. The negative multiplies in, so I have -3, -3, -6, 152, and then combine these two, and then I'll multiply by the 3/2. So this is 3/2, -3 plus 1, -2. And then -3 plus 5 is +2. And then -6 plus 2, this is -4. Then multiply the 3/2 inside. This gives us -4. Sorry, not -4. This gives us -3. Then 3/2 times 2 is just 3. 3/2 times -4, that is -6. Okay, so this is my AP. All right, so now that I have AP, I'm going to work out the dot product of AP and OB. So this is -3, 3, -6, dot, and then OB. What is my OB? This is 152. Okay, now the way the dot product is you just multiply the corresponding elements. So the first one, multiply with the first one, and then you add that to the second one, multiplied by the second one, and then you add that to the third one, multiplied by the fourth one. Okay, sorry, the third one multiplied by the third one. Okay, so here you will have -3 times 1 plus 3 times 5 plus -6 times 2. So this is -3 plus 15 minus 12, and this is in fact equal to 0. Then we can say that since the dot product, since their dot product is 0, then AP is perpendicular to OB. Okay, that is how you would solve that one. So it might have been a good idea to solve for AP in the first question, which carries more marks than in the second one, but in the end, it doesn't really matter. It wasn't too much work that we were doing. Okay, number 7. We're given a diagram that shows a metal plate made by fixing together 2 pieces, OBC. So we have OBC, this one that is shaded, and ODEA, the one that is unshaded. The piece OBC is a minor sector of a circle with center O. So that means you can draw another circle around like that. And the radius is 2r. So you can see it goes, this is r, and then that is r. And then the piece ODEA, the one that is unshaded, is a major sector of a circle with center O and radius r. Angle AOD, that's AOD, is alpha, and this is in radians, very important. Then A says, simplifying your answer, find in terms of alpha, pi, and r the perimeter of the metal plate. Okay, now the perimeter of the metal plate. So this is the plate that we have made. And remember that perimeter is the distance around a shape. So I would start here. I would go from A all the way to E and then to D. Then from D, I go to C. And then from C, I go to B. And then from B, I'm back at A. That means I've gone all the way around. So those are the distances that we want to add together to work out the perimeter. So our perimeter, this is AED. So this will be AED. So you go from A all the way, passing through E to D, and then you go from D to C, to here, and then you go from C to B, and then you go from B to A. And then you have walked all the way around the shape, and the distance that you have traveled is the perimeter. Okay, so we want to work out this distance AED. So we know that that is the major sector, and we know how to work out the arc length when you are given the angle. Okay, so if this angle here is alpha, this angle here is alpha, it means that this angle here is 2 pi minus alpha, because we know that the angles in a circle add up to 360, and 360 degrees, this is equal to 2 pi radians. Again, these conversions are in the formula sheet. So if this is alpha radians, then this angle over here is 2 pi minus the alpha. And then from the formula in the formula sheet, if you want to work out the arc length, so we know that S, the arc length, is equal to our angle theta in radians multiplied by the radius. So this is theta times r. So AED, this is our arc length. This is equal to the angle, which is 2 pi minus alpha, and then multiplied by the radius. Here, the radius of the circle is just r. So this is 2 pi minus alpha multiplied by r. And now DC. DC, we know that this is r, that is r, so this is r, and that is also equal to r. So DC is just equal to r. And then CB. CB is this one here. We're going to use this same formula over there because this is an arc, just the same way that this was an arc, except that it was bigger, but it is still an arc. So we are looking for which one? BC, CB. So CB, we use the same formula. This is theta, the angle, which is alpha, multiplied by the radius, and it is the radius of the shaded circle. The radius of the shaded circle is r times r. It goes from the center to C, so it's not just r. So it is r plus r, which is 2r. So this is alpha times 2r. So this is 2 alpha r, and then BA, that is just equal to r. Okay, simplify where possible, collect any like terms that you have. So here I see I have an r and I have an r. So this is 2 pi minus alpha r. Then I'm just going to write this one first. I have 2 alpha r, and then r plus r is 2r. You can factor out the r. We'll see if that will really make much of a difference. So here I can factor out the r. So if I factor out the r here, I have 2 pi minus alpha. And then here I have plus 2 alpha, and then here I have plus 2. So this is r, then I have 2 pi. Negative alpha plus 2 alpha is positive alpha, then plus 2. So this is the formula for the perimeter of this metal plate, simplified. Okay, again, it said you must simplify, so leave it like that, that's fine. Then B, in the case where R is 5 and alpha is 0.8, find the area of the metal plate. Okay, so here what you would do is you would work out the unshaded area and then work out the shaded area, and then you would add them together. So the total area, let's say that the total area, this is the area of the unshaded plus the area of the shaded. Now keep in mind that this is in radians. So if it involves any sine, cos, and tan, make sure your calculator is in radian mode. Okay, so let's start with the unshaded area. We know the formula for the area, it's given here. So I've been saying that all these formulas are given, but they are in fact given. Let me just scroll down to show you. If you have the paper with you, then you can just flip back. Okay, so where did I see that? Okay, so these are the formulas that I'm using. The first one I used was the arc length is equal to r times theta, theta times r, and this is the formula for the area of the sector. Okay, so all the formulas, I think just about every formula that we use is given at the back. Okay, so we want the unshaded area. So the unshaded area, we have our angle and we have the radius. So we just substitute. This is a half our theta. So we know that the area, just going to write down the formula of the sector. This is a half theta times the radius squared. So what is my theta here? My theta is 2 pi minus alpha. So it's a half times 2 pi minus alpha. And then my radius, what is my radius? My radius of the unshaded circle is just r. And then I'm going to square this. So first I'm writing down the formula before I then substitute the 5 and the 0.8. Okay, now the area of the shaded is also a half multiplied by theta. What is my theta here? Or what is my angle? The angle of the shaded sector is alpha. So it's half times alpha, and then multiplied by the radius squared. What is the radius of this shaded? We said it's r plus r, which is 2r. So I'm going to multiply that by 2r squared. Okay, so now I can substitute r is 5 and alpha is 0.8. So this is a half 2 pi minus 0.8 multiplied by r, which is 5 squared, and then a half multiplied by alpha, which is 0.8, and then multiplied by 2 times 5 squared. So exactly the way it is here is what you will type on the calculator. Okay, half times 2 pi minus 0.8 times 5 squared plus a half times 0.8 times times 2 times 5. Okay, and that gives us 108.5398 8163. Okay, and say leave it to 3 significant figures. This is 109, and this is centimeters squared. Okay. So number 8. Each year, a company donates money towards the prize-giving ceremony held at a school. The company increases the amount of money donated each year by 10% of the amount donated in the preceding year. The donation in 2010 was $1,000. A, find the total amount donated to the school during the years 2010 to 2018 inclusive, correct to the nearest Namibian dollar. Okay, so with this one here, you can see, let's see. Okay, we just want to find the total amount that was donated to the nearest 10 Namibian dollars. Okay, so here you can see this is a compound interest question. Okay, so what we do, see, find the total amount. Okay, yeah, this is a compound interest question because every year you add 10% of what you have already, so you can work out what you have using compound interest. Okay, so not compound interest, but series actually. Okay, so this is what we would call a geometric series. So this is a geometric series question, and it's important to recognize this because what one might be tempted to do is work out each of the amounts that they got in every year. You start 2010, 2011, and so on. You just keep adding 10%, and that's easy enough to do, but it's a lot of work, and with doing that, it's very easy to make a mistake. Now here you recognize that this is geometric because, let me see, maybe the first 2 or 3 years, you see in 2010, they got 1,000. Then in 2011, to find out how much they get, I just say 1,000 times 1.1 or 110% of this. And this will give me 1,100. And then in 2012, to figure out how much they get, I just take this 1,100 and then I multiply it by 1.1 or 110 of this. So I have this. This will give me 1,210, and then I would continue. So you can see that with each amount, to get the next one, I just multiply by 1.1. So this is in fact a geometric series or sequence, sorry, I should say sequence. So it becomes a series when I now add all the terms together. So geometric sequence. Okay, so with the geometric sequence, we need to figure out what is our A1 or the first term. The first term is 1000. What is my common ratio? R, that means what am I multiplying each term with to get the next one? That's 1.1. And then, because I want to find out the total amount inclusive, so I want to find out how much money have they given to school from 2010 to 2018. I need to know how many years that is equal to. So you count from 2010 to 2018. How many years is that? That is 9 years. So N is equal to 9. So what we are in fact asked to find, this is S9. So let me write down the formula. We know that Sn, this is given by A1 multiplied by 1 minus r to the power of n divided by 1 minus r. So we're finding the sum of the first 9 terms. This is A1. One here, it doesn't fit. So this is 1000. And then I have 1 minus 1.1 to the power of 9. This is divided by 1 minus 1.1. So this you type in on your calculator exactly the way it is. So we have 1000 brackets 1 minus 1.1 to the power of 9. And 1 minus 1.1 in the denominator. So we get 13,579.4761. Okay, now we are told to write it to the nearest 10 Namibian dollars. So the nearest 10 Namibian dollars would be, look at the 7 here, and the number that comes before it is a 9. Because it's a 9, it's bigger than 5, you add 1 over here. So the total donated to the nearest 10 Namibian dollars is 13,580 dollars. This is to the nearest $10. Okay, and you can try it the other way that I said. So first work out the amount they got, or not work out, it's given, the amount they gave in 2010. Okay, my pen is misbehaving. Then 2011, then 2012, and then keep going until you get to 2018. And then each of these terms, add them together. Keep adding, you will see that you will get the same amount. It's just that this will take you much longer to do than the way that I have done it over here. Then we're told that another company also decides to donate $1,000 in 2010. The company, however, increases the donation each year by a constant amount of A. So here, again, already in our minds, we should go up, because the first one was a sequence. This one should also be a sequence. So you can see that in 2010, they also gave 1,000. Then instead of them giving 10% more of what they gave in the previous year, they're saying, okay, in 2011, we are going to say $1,000 plus some amount A. And then in 2012, we'll say what we gave in 2011, which is $1,000 plus A, and then we're going to add A again. So they just keep adding an A. And if you think about that, what should come to your mind is that this is an arithmetic sequence. Okay, so you just keep adding an A to the previous number that you got. Okay, now find the value of A to which the total donation for the years 2010 to 2018 inclusive would be the same. So we're going to use this amount here to the nearest $10. So we want the total. So they want to say, okay, we've donated the same total over the years. So their total must also come down to 13,580. Now with an arithmetic progression, we need our first term, A1. A1, this is equal to 1,000. Then our common difference, this is A, okay, which we have to try and figure out. Now we know that the formula for, N is also equal to 9 years, because from 2010 to 2018, that is 9 years, because you've donated in 2010 and 2011. If you count all the years that you have donated in, that is actually equal to 9. Okay, so we know the formula for the sum of the first n terms in an arithmetic progression. This is given by n over 2 multiplied by 2 times our first term plus n minus 1 multiplied by the common difference. So we're going to substitute everything. So this 13,580, this is our sum of the first n terms. So we have 13,580. This is n divided by 2. Then we have 2 times A1, which is 1,000. Then n minus 1, this is 9 minus 1. And then our common difference, A. So we're trying to solve for A here. So this is, we can multiply by 2 and divide by 9 on both sides. So we have 13,580 times 2 divided by 9. This gives us 2 times 1,000. This is 2,000. 9 minus 1 is 8. So this is 8A. So on the left-hand side, okay, just solve it. I don't want to simplify too early. Okay, so this means we can subtract 2,000 on both sides. So I can have 8A plus 2,000. So I'm just switching the sides. I haven't done any calculations or anything. I'm just writing the left-hand side first. Then we have 8A. This is 1358 times 2 over 9 minus 2,000. And then A, this is 1 over 8, divide everything by 8. So the only reason I'm doing this is I'm trying to avoid rounding off too early so that my answer is as accurate as possible. So here, when you work this out exactly the way I have it there, we have 13,518. Okay, so this gives me 127 and 22 cents. I leave it to 2 decimal places because this is currency or money. Okay, so to 3 significant figures, you would say they donate $127. And you can try that. So every year they must add $127 to what they donated the previous year. You'll see that the values are actually very close, because even this 13,580 was not the exact value. It was rounded to the nearest 10. So even this one is also a rounded off value, but that's how you would do it. Right, number 9, just make this smaller. Number 9, the diagram shows part of the curve y is equal to 9 minus x squared intersecting the y-axis at 0, 9, so that's here. This is where it's intersecting, and the x-axis at 3, 0, so that point over there. Now, showing all the necessary working, find the area of the shaded region. So again, a formula from the paper. If you just scroll down, you have the area. This is equal to the integral. You're going to integrate from 0 to 3. And then you integrate the formula for y. So that's 9 minus x squared dx. So integrate this, because this is a definite integral, I'm going to put it in a box like this. So the integral of 9 with respect to x is 9x. And then here, this x squared, at the top I added 3, so I have x to the power of 3, and then this 3 is what I divide by, and then I have 0, 3. So with our definite integral, you don't write a constant of integration, because we're going to substitute these numbers 3 and 0 in there, and the constant of integration always disappears whenever you have a definite integral. So this is equal to, so you substitute the number on top, so you have 9 times 3 minus 3 cubed over 3, and then you subtract the answer when you substitute 0 there, so you have 9 times 0 minus 0 cubed over 3, so this is just 0. So 9 times 3 minus 3 cubed over 3 that you do on your calculator. This is equal to 18. So this is 18 units squared, because it's area. Okay, then B, it's just 3 bucks. Showing all the necessary working, find the volume generated in terms of pi when the shaded region is rotated through 360 degrees about the y-axis. So again, this one, just a matter of using the formula. So the formula is given by this, the volume. This is equal to pi multiplied by here, C and D, those are your limits. We'll work them out just now. And then we have f of y squared, and then we integrate with respect to y. So what is my y here? Y is equal to 9 minus x squared. That is the formula for the parabola. There it is. And then you make x the subject of the formula. So we have this x squared will come this side, so you have x squared, and then this one will go that side. So you have x squared is equal to 9 minus y, and then to find x, you take the square root on both sides. We have x is equal to the square root of 9 minus y. Okay, and then this f of y is what you are going to substitute over there. So our volume, this is pi, it's multiplying by the integral. Now my C and D, those are this 0 and that 9, where it's intersecting the y-axis. Okay, so I'm revolving around the y-axis. Everything must be in terms of, yeah, revolving around the y-axis. Yeah, okay, so this should be a 0 there. Okay, sorry, this is a 0, and then that is a 9, and then I take my formula for x. So when I'm revolving around the y-axis, my formula must be x is equal to something in terms of y, because I'm integrating with respect to y. There must be a y here. I cannot integrate this with respect to y, because I've treated as a constant. So I make y the subject of the formula here. So my function here, this is the square root of 9 minus y, and then I have to square it and then integrate with respect to y. So this is pi, the integral of 0 to 9. The square root and the square will cancel. I have 9 minus y dy. So when we integrate, the pi will remain outside. Again, a definite integral. We have our rectangle there. Integral of 9, this is just 9y. This was y to the power of 0, so I have 0 plus 1 divided by 1. And then here I have 1, so I have 1 plus 1, so this is y squared over 2. And again, because this is a definite integral, you don't need to put a constant of integration. When you substitute the 0 and the 9, the constant of integration always disappears. So this is pi. And then I substitute the 9, so I have 9 times 9 minus 9 squared over 2. Then I subtract when I substitute 0, so I have 9 times 0 minus 0 squared over 2. And this, we want our answer in terms of pi, so we don't want a rounded off value. So this is pi multiplied by 81 minus 81 over 2. So this is pi times 81 over 2. So this is 81 pi over 2, or you can write this as 40.5 pi. And this is units cubed, because this is a volume. Okay. That is the volume. All right, number 10. The line y is equal to mx plus 4, where m is constant, does not intersect the curve y is equal to x squared minus 2x plus 20. Find the range of values of m. Okay, so we know that if we were trying to find the point of intersection of a line and a curve, we would equate them and then solve for x. So let's proceed in that manner. So we would say mx plus 4, this is equal to x squared minus 2x plus 20. And this is quadratic. We want everything on the left, 0 on the other side. So I can take this one that side and this one that side. So I have 0 here, and I have x squared and minus 2x minus mx, and then 20 minus 4, this is 16. So just changing the order, I have x squared minus 2x. In fact, let me factor out the x. You can see here, x is common, so I factor out the x. Then I have positive 2, because when I multiply this, they give me negative, and then m, then 16. Okay, and this is equal to 0. So this is quadratic. I want it in standard form. So it's ax squared plus bx plus c. So I have x squared plus, this is negative 2 minus mx plus 16 is equal to 0. Okay, so that might have been a little bit confusing, but this negative here, I just leave it there. And then this x, I put it over here. That's basically all I did. And then you can multiply the negative inside like that. So I have negative x 2 plus m. This is the same as negative 2 plus m, and then the x, and then multiplying it inside. All right. Then from here, we are told that they do not intersect. So that means this equation has no real solutions. And when a quadratic equation has no real solutions, it means that the discriminant is less than 0. So what we need to do is figure out when is the discriminant less than 0. And we know that our discriminant delta, this is given by b squared minus 4ac. So we have to identify what is my a. A here is 1. B here, this is negative 2 minus m, so whatever is in front of the x. And then my c, this is 16. Okay, so now you just substitute. What is our b squared? This is negative 2 minus m squared, then minus 4 times a times c, so 16. And again, because we don't want these lines to intersect, this must be less than 0. Okay, so here you can expand this out, but remember that negative 2 minus m, this is negative 2 plus m, and this is also the same as negative m plus 2. They are exactly the same. Okay, and we know that if I have negative 1 and I square it, this is the same as 1 squared because the negative goes away. So this negative 2 minus m, I can just write this as m plus 2 squared, and then negative 4 times 1 times 16, this is negative 64. So this is less than 0. Then multiplying this out, we have m plus 2 times m plus 2 minus 64. This is less than 0. We have m squared, m times m, and then we have 2m. And then we have 2m. Then 4 minus 64, this is less than 0. Okay. This is m squared plus 4m minus 60 is less than 0. So this is a quadratic inequality. Now, when we're solving quadratic inequalities, there are a few steps that we need to work out. So with the quadratic inequality, step number 1 is you must write it in standard form. Everything on the left-hand side, 0 on the right. Then second thing you need to do is you need to factorize. So you will factorize, you look for two numbers that when you multiply them, the answer is minus 60. And when you add them, the answer is 4. So that's negative 10 and positive 10 and negative 6. So we have m squared plus 10m minus 6m minus 60 is less than 0. Then we have m plus 10 minus 6, m plus 10. Then this is m minus 6, m plus 10. This is less than 0. So that's step number 1. Or step number 2, after you have put it in standard form. So number 1, standard form. Number 2, factorize. If it is not possible to factorize, you will do the next step using the formula. But most of the time with these questions, you are able to factorize. Now, step number 3, what you need to do is find the critical points. Now, the critical points, very easy to solve. You just take this factorized expression. So you say m minus 6. And then m plus 10, and you equate it to 0. That's step number 3. We're still solving the inequality, but at this step, it's equal to 0 because we're looking for specific points. So this means m minus 6 is 0, or m plus 10 is 0. This means m is 6, or m is -10. Okay, so these are what we call our critical points. Okay, now once you have these critical points, what you're going to do is you are going to draw a number line. So this is a number line from -infinity to +infinity. And then you divide the number line in, you plot the 2 points actually. And the 2 points will divide the number line. So I have 6 and I have -10. So -10 comes first. So you put -10 here. So that's -10. And then 6 is somewhere there, right? And then your number line, you extend it and form a table like that. Okay. Then you go back to the factorized form. So we're now at step number 4. This is step number 4. Now step number 4, here you take your factorized forms. I have m-6 and m+10. Or just m+10 first and then m-6, but it doesn't really matter. Now what you should do is you started with a number line and you divided it into 3 regions. Okay, so these are numbers that are less than -10. These are numbers between -10 and 6, and then these are numbers that are greater than 6. What you do is you pick a number in each of the regions. So for example, here I would pick -1000. So it doesn't matter what number it is, as long as it is in that region. And then here you would pick a number between -10 and 6, let's say 0. And then here I would pick maybe 10. So again, the number doesn't matter. All you're interested in is the fact that the number is in the region that you have picked. Okay, so what you do with this number that you have picked is you substitute it into these values. So you say m, instead of m, I put -1000. So I say -1000 plus 10. And now what I'm interested in is not necessarily the value that it's -50 or -75, or not in the exact value. I'm interested in whether it is a positive value or a negative value. So when I say -1000 plus 10, my answer is -990. So I'm not going to write -990. I'm just going to put negative. So I've taken this number, this representative of the region, and then I substitute it in there. And then I'm interested in the value, whether it's positive or negative, only not that it's -990, just that it's negative. Then I do the same thing, this -1000, say -1000 minus 6, the answer is -1006. What I write here is not -1006, I write negative because I'm only interested in the sign. Then I move on to the next column, so I say 0 plus 10, the answer is 10, 10 is positive, so I put positive here. Then the next one, I say 0 minus 6, my answer is negative. Then here I say 10 plus 10, my answer is positive. Then here 10 minus 6, my answer is positive. Then I add one more row. And this row, I go back here where it was factorized, exactly the way it was factorized is what I put in the last row. So I have m minus 6, m plus 10. And then if you look at these two brackets, you can ask yourself, what's happening to these two brackets? They are multiplying. So I can say this one times that one, that will give me this. So I should do the same thing to their signs. So the first column here, I say negative times negative, that gives me a positive. And then the second column, I have negative times positive, that gives me negative. And then here I have positive times positive, that gives me a positive. Okay, so that's what I have. So this is what, oh dear. So this is what we call a sign table. Okay, so step number 4 is a sign table. Then the last step, number 5, is answering the question that was given. So this is where you come to this point here, after you have factorized. So you look at this last part over here, this less than 0. You ask yourself, less than 0, what does less than 0 mean? So what does less than 0 mean? So less than 0 means negative. That's what less than 0 means. Okay, and then you go to the last row in your table, and then you look for negative. This here has positive. That's not what I'm looking for. I'm looking for negative. This one here has negative, so that is what I'm looking for. This one here has positive, not what I'm looking for. Then to answer the question of when is m minus 6 multiplied by m plus 10 negative, the answer is when m is between minus 10 and 6. So the solution will be from minus 10 to 6. And that is how you would solve this question. So it involves you doing a little bit of thinking, but then applying what you know about solving quadratic inequalities. Okay, B, explain why the equation 3x squared minus kx minus k squared is equal to 0, where k is a non-zero constant, always has 2 real roots. Okay, so here we have 3x squared minus kx minus k squared is equal to 0. So it has 2 real roots. Again, that has to do with the discriminant. So we know that real roots means that the discriminant is greater than or equal to 0. That's what real roots. But then when we have two of them, 2 that are real, it means that the discriminant is strictly greater than 0. So all we need to do is show that our discriminant is greater than 0, and then that will mean it is real, the roots are real, and because it is not equal to 0, it's not possible to have a repeated root, it means we have 2 of them. So it's already in standard form. Here our A is 3. Our B is negative k, it's whatever is in front of the x, and then our C is negative k squared. So this whole thing, say this whole thing over here. Okay, so now we work out our discriminant, which is b squared minus 4ac. B, this is negative k, square it. Then 4 multiplied by a, which is 3, and then c is negative k squared. This negative k squared is just positive k squared. Then negative and negative, this will give me positive. This 4 times 3, this is 12 k squared. So this is 13 k squared. Okay, so now we have to say something about this number. Now 13 is positive, so 13 is a positive number, and k is not equal to 0, so k squared is greater than 0. So if I have a number 13, which is positive, and I multiply it by another number which is positive, then the answer is positive. So therefore 13k squared is greater than 0. Okay, and then since the discriminant is greater than 0, then we can say that we have 2 real roots. So we can say that since, so you will obviously space this much better here than I have done. So since the discriminant is 13k squared, which is greater than 0. The equation has 2 real roots. Okay. Then number 11, we have the equation of the curve y is equal to x squared plus 16 over x. We have to find the coordinates of the stationary point. So to find the coordinates of the stationary point, we know that at the stationary points, the derivative dy dx, this is equal to 0. So we have to find the first derivative and then equate it to 0. So we have y is equal to x squared plus 16 over x. This we can write as y is equal to x squared plus 16x to the power of -1. And then we find the derivative. So dy dx, we know that this 2 comes down, so it's 2x, and then at the top, we decrease it by 1, so it becomes 2 minus 1, which is 1. And then the next one, we have 16. This -1 comes down. And then x at the top, we're saying -1 minus 1, which is -2. So this is 2x minus 16x to the power of -2. And then we know that at the stationary points, dy dx is equal to 0. So at the stationary point, we have a 2x minus 16x to the power of -2 is equal to 0. This means that 2x is equal to 16x to the power of -2. And then this we can write as 2x is equal to 16 over x squared. Then we multiply by x squared on both sides. So we have 2x cubed is equal to 16. Divide by 2 on both sides. We divide by 2. We have x cubed is equal to 8. This means that x is the cube root of 8. So x is equal to 2. Now that you have the x coordinate, you're going to substitute into the formula for y. So here to get the y coordinate. So you have x squared. So we have 2 squared plus 16 over 2. So this is 4 plus 8, which is 12. So our stationary point is 2, 12. Right, then find the equation of the normal to the curve at the point 4,20 rather. Okay, so what we know is that the tangent, this is perpendicular to the normal. Okay, so if we find the gradient of the tangent, we can always work out the gradient of the normal using the fact that their product is equal to -1. And the gradient of the tangent, so gradient of the tangent, this is equal to the derivative dy dx. And this we have already worked out over here. 2x minus 16 over x squared. So dy dx, this is 2x minus 16 times x squared, or 16 over 16 times x to the power of -2, or write it like this. So we find the gradient of the tangent by substituting the x coordinate here. The x coordinate is 4. So we have 2 times 4 minus 16 over 4 squared. So this is 8 minus 1, which is equal to 7. Then the gradient of the normal, this is negative 1 over 7. So remember that the gradient of the normal times the gradient of the tangent, when I multiply them, I should get negative 1, or it is the negative reciprocal of that one. So now that I have the gradient, you can just substitute into the formula y is equal to mx plus c. So we know that y is equal to mx plus c. What is my y? It's 20. What is my m? Negative 1 over 7. What is my x? It's 4. And then I solve for c. So 20 is equal to 4 over 7 plus c. This means that c is equal to 144 over 7. And then you write down the equation. Y is equal to negative 1 over 7x plus 144 over 7. Okay, right, so the equation of the normal is this one over here. Okay, number 12, the last question. A function f is such that f of x is equal to the square root of 2x plus 2 for x greater than 2, where, for x greater than or equal to k, where k is a constant. Find the least possible value of k. Now here you can see that we have a square root, and if we want to get real values from the square root, we need to make sure that what is under the square root is positive. So we need 2x plus 2 to be greater than or equal to 0. Then we solve this. This means that 2x is greater than or equal to negative 2, divide by 2. This means x is greater than or equal to negative 1. So it can be greater than or equal to negative 1. So the least possible value of k is negative 1. Okay. Then B says for the value of k found in part A above, find the expression of f inverse of k and state its domain. So finding the inverse is pretty simple. You have y is equal to the square root of 2x plus 2. Then to find the inverse, you just switch x and y. So you have x is equal to the square root of 2y plus 2, and then you proceed to make y the subject. So to get rid of the square root, you square both sides. And then this 2 will go this side. You have x squared minus 2 is equal to 2y, and then you divide by 2 on both sides. So we have x squared minus 2 over 2 is equal to y. So then our f inverse of x, this is x squared minus 2 over 2. And of course, keeping the restriction of k that we got above, x is greater than or equal to negative 1. Now our domain, these are the values that we're allowed to put in here. This is the set of all real numbers and numbers from 0 to infinity. So it's a set of all the real numbers, and then you intersect that with the numbers, the positive numbers, because the domain of a function is a subset of the range of its inverse. Or let me see if I'm saying that right. The domain of the inverse is the range. The range of the function is the domain of the inverse. or something like that. Okay, I don't know if I'm saying that correctly. So if I want to work out the range of a function, I just work out the domain of its inverse. Okay, I think that's saying it more clearly. If I want to work out the domain of the inverse, I need to know what the range of the function is. And that's where I'm getting this from. So this is the range of f of x, okay? Because this is a square root function, and from a square root function, you will always get either 0 or a positive number. So you cannot get negative values, so it must be incorporated in the numbers that you get there. So our domain is just x is between, is greater than or equal to 0, okay? Or you can write it like this, it goes from 0 to infinity. Okay, then the last part for the values of k found in part A, sketch the graphs of y is equal to f of x and y is f inverse of x. Label the graphs and indicate the intercepts of each graph with the coordinate axis. Okay, so with the first one, the square root y is equal to the square root of 2x plus 2. We know that when x is equal to -1, that's when we get 0 here. And all our square root functions, they form an arc like this. They're a parabola that opens up on the y-axis. So they go like that. So it's a half parabola. So a normal parabola will go like that. And then this point here, you equate that to 0. So you would say 2y, sorry, the square root of 2x plus 2 is equal to 0. And then you solve. So you say 2x plus 2 is equal to 0. 2x. Sorry, what I meant to do is that will give me this one, which is -1. Not -1. Yeah, it will give me -1, sorry. This point here, x is 0. So I work out the square root of 2 times 0 plus 2. This is square root of 2. So this point here is square root of 2. Then label. So I've drawn it a little bit flat, but it's actually an increasing function. It goes on, but very slowly. Okay, then to get the inverse, you would draw the line y is equal to x, and then you reflect that. So this point here will be reflected here. This point will be reflected there, and then form an arc. So you draw like a mirror image, and they must cut at the same point. This is square root of 2, and then this is -1. Okay, so this is y is equal to the square root of 2x plus 2. And then this is y is equal to x squared minus 2 over 2. Okay, so this is your f of x, and then this is your f inverse of x. All right, and then the last part, find the value of f prime of x. So here, f prime of x, I'm guessing that means the first derivative when you substitute into the first derivative. So we have f of x, this is the square root of 2x plus 2. Here you can write this as 2x plus 2 to the power of a half. And then the first derivative, what happens is the half comes down. Then the inside stays exactly the way it is using the chain rule, and then you say half minus 1, which is minus a half, and then you multiply by the derivative of the inside, which is 2. The derivative of 2x is 2, the derivative of this is 0, 2 plus 0 is 2. So this half times 2, this will just give me 2x plus 2 to the power of minus a half, and this is just 1 over the square root of 2x plus 2. Then you can substitute 7 in there. We have 1 over the square root of 2 times 7 plus 2. This is 1 over the square root of 14 plus 2. This is 1 over the square root of 16, which is 1 over 4. Okay, and that is how you would answer these questions.